Yo! Okay, let's go straight into the topic. We are going for Chemistry Chapter 2 because Chapter 1 is something that's kind of common sense, just the things that you have learned. So let's go straight to Chapter 2, SPM Syllabus. Now, starting off, you need to know about matter. Matter is basically just things which has mass and occupy space, and it is made out of tiny and discrete particles, which particles we later know there can be three types of particles: atoms, molecules, and ions. Let me repeat. Matter, things that have mass and occupy space, they are made out of discrete particles. Then we have particles to go into three more branches, which is right here. Firstly is atoms. Atoms are the smallest type of particles that exist on its own. So it's basically if you have pure, let me think of one metal, pure copper. So copper, all this one round thing that you see in your picture, yep, those are atoms. Now, molecules is two or more atoms chemically combined together. Now, if you have seen all this kind of H2O picture where they have round circle, round like this, round circle, then two more smaller circle, yep, that is called molecule because it has 1, 2, 3 atoms in that one molecule. Moving on, we have ions, which basically are just charged particles. We will learn more in depth about this. So don't worry for that for now, just remember it as charged particle. That's why sometimes you see us writing, you can see Cu2+, Fe2+, all these 2 minus 2 plus are their charge. This we call them ions. Okay, moving on to the next one, is going to be about, you know what, let me zoom in a little bit for a better view. Okay, that looks better. Okay. Now we have the state of matter. So state of matter, there are 3 of them, and our teacher are going to ask us to how to draw. And if you're sitting for SPM syllabus, for solid you need to draw 3 times 3. Liquid, you need to times like 4 or 2 or 3 connected together, and they are separated. There must be some connected together and some separated, because this is actually how it actually looks like in real life. It's not like all are separated. There are a few that are still connected together, a little bit of solid kind of thing. There are still forces of attraction between these atoms. Well, whatever, just remember solid, connected all, liquid, a little bit of gap between, some are connected, and gases, all are completely separated. Okay, moving on to the description. Basically, the distance between atoms, it will be touching, far apart, very far apart. Now they will have a high forces of attraction among each other for solid, of course, so that they can hold together very strongly. While for liquid, it will be a little bit weaker than solid, and then you have your gases, which is just very weak. And then in terms of how they move, it's actually just vibrate and rotate at a fixed position for the solid. The atoms, they kind of just stay together, in which they kind of have 2 atoms together. All they can do is just like vibrate and rotate and just shake in their own position, because they are held so tightly together, but they want to move, they have the energy, but cannot, they are like concealed by it, so they will just stay. Next one is going to be like the liquid. Is similarly is vibrate and rotate, but you can move throughout the whole places inside that you can move. And gases, the atoms, they vibrate, rotate and move freely. That's the difference. And other than that, I believe all others are quite fine. Okay, so moving on. Basically vibration is only when it receives external energies when it's heated. Okay, moving on. We have the kinetic theory of matter, which is related to, you need to know the basic stuff. Is like melting, freezing, evaporation and boiling, condensation and then sublimation. I think all these things are kind of common sense already. We have learned it in Form 3, just revise your one in Form 3. And remember, sublimation apply for both solid to gas and gas to solid. Now, there are a few things that we call it's like points. So basically points, you need to kind of like freezing point or melting point or the evaporation, is the evaporation point? Nope, only freezing point and melting point. And these points, we are going to say 2 components related to it. Temperature at which what turn into what. That's the state. First one is the temperature at which, because at point we are describing like 0 degrees Celsius is the freezing point, or 0 degrees Celsius is the melting point, 100 degrees Celsius is the boiling point for water. Yeah. So, by the way, all the temperature previously was only for water. Different substance has different kind of points. So, basically, for these points, you need to, when they ask you to define the points, you need to go for temperature at which what turns into what. And always remember this, it comes up quite frequently in your exam. So, freezing point is the temperature at which a solid turns into a liquid. Liquid turns into a solid. While melting point is in temperature at which a solid turn into a liquid, melt, solid, liquid. Then boiling point is going to be a temperature at which liquid turns into a gas. Now, moving on, the next thing in our syllabus is related to naphthalene. Naphthalene, if you want to know what it is actually that white round colored thing in the toilet bowl, that one that creates some kind of odor that says to be freshening our air, that white colored thing is naphthalene. So it has a heating curve that kind of goes up, stay constant, goes up, stay constant, go up. Now it stay constant is when, okay, this is how it goes. It's let's say we start off with, this one is melting, this one is heating, so the temperature is increasing. This is temperature, this is the time. Okay, so it started off with a solid, the temperature will keep on increase until at the point when the solid starts to melt, then only the temperature will be consistent. Here is why. It is consistent because all the heat energy are being converted into kinetic energy. So you know the heat energy, instead of like being detected by that thermometer that is raising, it is being converted into kinetic energy. So the heat energy immediately gone into kinetic energy. That's why temperatures stay constant. So afterward it becomes converted to kinetic energy, and those kinetic energy are used to overcome the forces of attraction between the particles, and thus it changes from solid. It's basically the process in which it changes from solid to liquid. So the mixture has both solid and liquid. And if SPM exam they just ask you and then they ask you to give 2 marks, so your 2 marks is going to be constant because heat energy is being converted to kinetic energy, and that kinetic energy is used to overcome the forces of attraction between particles. Okay, so the next one is going to be cooling curve. It's somehow like the opposite, obviously. So you got for a gas. Okay, let's not put here, I don't have gas. If you have a gas, it will be another one. So if you go from gas, then gas plus liquid, then liquid cooling down, liquid plus solid, then solid completely cool down and go down. Okay, so it stays constant because the kinetic energy is lost as heat energy. There's like a stronger forces of attraction being formed because all those kinetic energy are being lost as heat energy. Now you see here is cooling, right? So this means theoretically temperature needs to go down. But no, there's like an opposing force pushing it up so that it stays still. And that opposing force is the heat energy that they just released. Imagine there's a thermometer here. So the heat energy is the kinetic energy is being lost as heat energy. So heat energy is constantly being lost, so the temperature does not go down. That's what is happening. So basically cooling curve is it stays constant because the kinetic energy is lost at heat energy to create a stronger forces of attraction. Yep, they do not have the kinetic energy to move around. They kind of just stay still. That's when we say the forces between two of them are stronger. They hold together tighter because they don't have the energy to want to run around. Yep. Okay, that's it for part 1. Let's move on to part 2.